Welcome, Hornets, and thank you for joining me today. We're going to be taking a look at working with the multiplicity of higher degree polynomials. So what I wanted you to be aware of is that when we are talking about polynomials, as we saw the other day, or in the previous video, taking a look at x to the fifth, if I look at this function, f of x equals x to the fifth, what you'll notice is that if I were to expand this out, I have 5x's, which means that there are 5 zeros in this polynomial, but the zeros are all the same. Now, when we talk about zeros, we are talking about x-intercepts. Well, this is what is referred to as a multiplicity. The number of zeros that are equal or exactly the same is what is that multiplicity. For example, if I were to give you the polynomial f of x equals x plus 1 to the second power and x minus 2 to the third power, we can clearly see that there are two zeros that are the same here, x plus 1, x plus 1, meaning that negative 1 happens twice. This is a multiplicity 2, also known as a double root. Double meaning 2. In this one right here, where we have x minus 2, the quantity cubed, that means that x minus 2 occurs 3 times, and as a result, 2 is a root 3 times, which we refer to as a triple root. This is a multiplicity of 3 versus a multiplicity of 2, also known as a double root. We refer to MR, multiplicity root 2, or double root, and triple root, or MR3. That means my first problem that I gave you had a multiplicity MR5, and it is a multiplicity of 5. Now, after we reach triple root, I'm sorry, but there is no special word after that. It's not going to be the quintic root, okay? We just call it MR5. And these are what we call multiplicity. And they tell us things about the graph. For example, if I'm dealing with a quadratic, I know that the quadratic reaches a tangent on the x-axis and moves and bounces off. So it touches the x-axis as a tangent and then moves off. A cubic, as we saw in the previous video, is going to pass through like a cubic would, and it gets a little bit flat, unlike a line which is straight through. This is simply a little bit of a curve, and it has that cubic shape to it as it moves through. And what this does is it allows me to put together my graphs and graph quickly by using my left end rule, my right end rule, based upon the highest degree of the polynomial, whether it is opening upward if it's an even highest power, downward if it's an even highest power, both going the same direction, but has a negative leading coefficient versus a positive leading coefficient. Dropping to the left and moving up to the right when we have a positive odd power. And once again, those are our left and right end rules, and it has a positive leading coefficient. And it rises to the left and falls to the right when it has a negative leading coefficient. Now, we put these together in order to make a quick graph. So let's take a look at this f of x again, and I'm going to put it onto the piece of paper. F of x equals x plus 1, the quantity squared, times x minus 2, the quantity cubed. Now, you'll notice in this polynomial, the highest degree is x squared times x to the fifth, which means our highest degree is a fifth power. The coefficient is 1. It is an even. So we now know certain things about the graph. First of all, the graph has a 0 at negative 1. The graph has a 0 at positive 2. The graph has to go down to the left, goes up to the right. Because x plus 1 has a double root, it's going to form a tangent at the x-axis, whereas on the 2, which is a cubic, is going to have that cubic shape going through. Now we can clearly see that if we were to take negative 2 and cube it, we're going to get a negative 8. We multiply it by 1 squared, and we now know our y-intercept is down here at negative 8. And our graph has to go through, probably going to keep going down a little bit, and then zooms up and connects with the cubic, and then continues with our right-end rule, and the bottom goes down with the left-end rule. And you'll notice this point of extrema, called a relative minimum, or that's shown here, at the moment can only be found by using our calculator. And that's why we use that TI-83, TI-84, or TI-84 in this case plus CE addition. I recommend you get a calculator if you have not already gotten one. It'll make it easier for you to go through the work. So what we do is we can now find things where our y-intercept is, continue down to our relative minimum, then move up, connecting to our cubic, and then moving up to the right. We have our quadratic bounce right here and moves down to the left. And all of this together gives us a rough sketch of this polynomial x plus 1 squared times x minus 2 cubed. And everything in this section is basing us or trying to help us to graph quickly without having to make a table of values and find all of the intermediate points. Please don't worry about this relative minimum. This is something that you're actually going to find out how to find when you reach your AP Calculus class. And until then, we just approximate. We'll look at our graph and we'll try and find it with our calculator. If we don't have our calculator and we have to do it without, we just have it keep going a little bit and then move up, and we do not worry about the minutia. Okay? Now this is the whole idea of multiplicity and roots working with the right end and left end rule. Let's take a look at another example and see if we can't work on another one. Let's take f of x, and we're going to have it equal x. Let's do x plus 2 double root. Let's do an x plus 1 triple root. And then let's do, let's be clever and do an x minus, let's do x minus 2 squared. Now you'll notice that this is going to end up being a 7th degree polynomial. X squared, x cubed times x squared is giving me an x to the 7th. That's an odd power. Being an odd power, it's going to drop to the left. It's going to rise to the right. We have our zeros. Those zeros are at positive 2, negative 1, and negative 2. Now at negative 2, since we're coming up, since we were falling to the left, we're going to have to come up, reach that double root. Here we're looking at that cubic at negative 1, which means it's going to have to turn fairly quickly. Give us the cubic. Let me redraw that. Once again, we want to try and get used to that cubic shape. Redraw that shape again so it is actually cubic. Going up that way, down that way, and we connect. We can see our y-intercept. To find the y-intercept, we take the 2 squared, we take 1 cubed, and we take 2 squared. Notice this is going to give me 4 times 1 is 1, times 4 is 4. Pardon, let's try that again. 4 times 1 is 4, times another 4 makes 16. This is shooting up and goes through 16 before it has to curve back down again. And once again, because it's a squared, it's going to form that double root, bounce, and then go up, following our right-end rule. We're now looking at our double root our triple root, and our double root. We have our y-intercept that gives us some idea where we are, and we don't worry about that relative maximum that we have here. That's something we'll learn with calculus, or we use our calculator in order to find. This gives us a close approximation of what this polynomial will look like. And if you'd like to find out, put it in your calculator, hit zoom 6. Remember, you may have to expand your window. That will require you to hit the window button and change your y-axis so that your y-max is higher. Since we were looking at 16, our y-max is probably going to want to be somewhere around 20 to 25. If we don't see that relative maximum when we do our graphing, we may need to expand our window more. And then once we have it fully in the graph, we can stop changing our window. And we can then see what it looks like, and it should look something like this. Notice that there's another relative minimum right here that we're not worrying about. That'll be taken care of in calculus. So will this relative maximum. Alrighty, that's the basics for working with an odd power. Let's take a look at an even power. Let's look at x plus 2, the quantity squared, times x minus 1, the quantity squared. With this polynomial, we can see that we have two double roots. We can also see that we have a power of 4, with the leading coefficient is a 1, a positive number. That means that when we put this on our graph, we're going to locate positive 1, we're going to locate negative 2, we're moving up on the left side upward, and we're moving upward on the right side as well. Once again, they're going in the same direction, being an even highest power. We know we're going to have to be coming down, and we're going to hit that double root. We know on the other side we have a double root, and we have our y-intercept at positive 4. So our graph is going to do something like this. Once again, having our relative maximum there, and finishing with our graph moving up, following our left and right hand rules. Notice we have our two double roots. Our relative extrema is somewhere in between. Don't worry about whether you put it on the left side or the right side. I figured it would be somewhere in between negative 2 and positive 1, and that would put it in the second quadrant, which is why I did that. We wouldn't really know until we get to calculus and are able to find it. This is our example of an even degree working with using our multiplicity and our left and right hand rules to create a sketch of a polynomial function. Once again, notice that it is smooth and continuous. It follows that right hand rule, both moving up with the positive coefficient and the highest power that is even. Thank you very much. I hope this has helped, and we will continue in our next video. Please take care, be safe, and be kind to each other. Remember, it is easy to be mean, so try to work harder and be nice to each other. It's the best we can do for each other. Thank you very much, and take care. Bye-bye.